first person that we will be inviting on stage in a minute is Michał Kołtowski.
Yeah, so fun. So what can we say about Michał from his private life? So he shared with us information that he has a sheepdog that also helped him take care of his children.
And he has 4, just 4, like you say,
Kids,
right?
not dogs.
4 kids, 1 dog.
Yes. In the office, Michał is an agile coach. I know that he's using very sophisticated names for what he does. I call it change agent and the agile coach in dispatch consoles. Mm-hmm. And he's a very skilled talker and a very influential person, and he's helped a lot of people, including myself. Okay. In his speech, Michał will be talking about his experiences about setting up continuous integration, continuous deployment at scale, which is a very important subject in the scale agile transformation, because very often the value that we deliver is a product of integration between some components of a system. So let's welcome Michał. Come on stage.
Thank you. A friend of mine gave me a tip that I want to share with you. This tip is how to improve your jogging abilities by brushing your teeth. Okay? So, you know how to do the teeth brushing. This is a fairly easy thing to do. You start on top, left side, right side. Here's a timer, 30 seconds you can use to actually measure that you spend half a minute one side, half a minute the other side, then you go to the bottom, half a minute. That's the easy part. Now, the jogging part, a friend of mine, he's into orienteering, which is eventually jogging in the forest, with a map and a compass, trying to find the checkpoint, register there, and do it quicker than all the competitors. So that's essentially the orienteering thing. Now, the important part of improving your jogging abilities is that when you do your brushing, you lift your heels up off the ground and then put it back. And do it while you're brushing teeth. And you do it constantly during the whole process. And you do it a couple of times a day, depending how often you brush your teeth. And then you significantly improve your muscles around your ankles. So you significantly reduce the risk of twisting your ankle when you're jogging in the forest and stumbling on a rock or something, right? So that's an easy thing. I have a couple of those for those of you who would like to have one, so you can share them among each other, and you'll need it at the end of this lecture, so keep it. It's an important thing. As technical difficulties. Well, I can't see it. Okay. Back again. Or not. Oh, where is it? Maybe I'll do it like presenter's view. Get this one here to me, or not. Okay, we're set. Are we? Okay. A little bit of an embarrassing start, but let's carry on. Do you know what this is? What this thing here is? It's not Pendolino, and it's not what you think. It's not Pendolino, it's Shinkansen train. It's Shinkansen train, it goes from Tokyo to Osaka. What's special about this train? It's fast, yes, one thing, that's definitely his fast, but that's not the answer I expected. It's always on time, so it's always on time. You know, the average, actually I checked it on Wikipedia, the average delay of this train on this route is 24 seconds on average during the whole year, which is awesome result, especially if you have experience with Polish trains. So that's That's kind of the thing. And that is a very important thing about this train, that it is on time. And why is it always on time? It was designed to be on time, right? So it's not that it's built like it has a huge engine or it can go really fast, which it can actually, but the whole environment around it was also designed to be fast, to be on time, right? So there are no like crossroads, no pedestrian walks around it, so there's nothing that influences. And by the way, this 24 seconds is also including all the natural disasters thing, like heavy snow that slows the train. So it's 24 seconds, including all the things that you can't control. So this is an awesome result, but it was designed to be that awesome. And the thing about your continuous integration that I want to talk to you about today is that you have to design it to be fast. And this is a key element of my speech. So, as Michał said in the beginning, we all are involved in large projects. We all deal with lots of engineers working at the same code base at the same time, right? So, if you don't design your continuous integration, continuous delivery system in a way that is fast, you will not only disappoint your customers with inability of delivering software whenever they want you to deliver it with your fixes, new features, etc. Not only will disappoint your customers, you will get your engineers frustrated. You will frustrate your engineers because they deal with that system on a daily basis. They want to integrate their code a couple of times a day, if they are good engineers. So this is a key element for keeping your customers and your teams happy. Okay. As much as I'm a fan of emergent design and Uncle Bob's teaching, so the so-called agile design, and I really admire that. There are certain things you know that are going to happen, and you don't have to wait for them to emerge. So you can design things up front, and this is actually a wise thing to do. So what is the first thing that, from my experience, is that is going to happen with your continuous integration? It will become slow. It will become so. You are working in a large project, you keep adding tests to it on different levels, the whole system becomes slow. And this is a thing you don't have to predict. Well, you don't have to wait until it happens. This is a thing you know from the very beginning it will happen. So you can design your continuous integration in a way that takes this into account. How? Let me start with an example, okay? Do you know what this is? You're close. This is actually Cyclone. And I'm talking about Cyclone because this was one of the environments, testing environments that we created in dispatch and content logging department. It was for running box test environment. We called it Cyclone. Actually, it was called before I joined the department, so I assume it was because it was supposed to be that fast. Now, you have to keep in mind that we kept adding tests to it. We had a couple of thousand POC level test cases in it, and it took about 12 hours to execute. Well, when I joined the department, this was not a problem because we had a product built once per 2 weeks. So if you have a build once per 2 weeks and a week of manual regression testing, 12 hours for automated testing is not that bad thing. Now, we wanted to switch to continuous integration mode. With that kind of approach, we were able to do nightly regression testing, right? But it was still too long, right? So we decided, okay, how are we going to make those tests faster? The obvious Answer is run them in parallel, split them into smaller chunks, run them in parallel. Guess what? We did that. We bought a couple of machines, actually dozens of machines, and split it, run it. They started failing. Why? Apparently, they were not independent. And we did not know that because they kept been running in the same kind of order for the whole time. So, getting back to designing things fast, even if you don't design your test cases from the very beginning in a way that are run in parallel, at least make an effort to run them in random order. Okay? Run your test in random order to eliminate dependencies between these tests and instabilities in the test execution. This is another thing that will definitely happen. And you know that from the very beginning. Your tests will fail, right? People will be integrating code, the test will fail. That's what they are supposed to do. When something gets broken, they will fail. You need to design your system to deal with that. What do you mean, deal with that? Like, how do you deal with that? You fix it, but when you fix it, right? So what happens if your tests fail? Your integration system goes red. What do? You create some sort of promotion mechanism. So like say, after unit tests, I'm promoting to another layer. If it fails, I'm not promoting. And then component layer gets only run on promoted artifacts. And then, I don't know, server level, client server level, that is what we have. And then system level, do you promote them and don't let the things to promote? Or maybe you don't. Maybe you just stop your engines and say, well, we're not going to integrate anything until this gets fixed, and somebody works on that. There's also a thing that you need to keep in mind, that you need to build and design the culture around it as well. It's not only the environment itself, but also the processes. Because who's going to fix those issues, right? Do you need some sort of a sheriff to let people know that there's something that they need to fix? It's not only the system itself, but also the culture, the process around it that you need to design as well. Okay, so another rule that I want to emphasize here, that you can actually, from my experience, if you follow that, you will be much more successful, is make the feedback something personal. So the feedback from continuous integration has to be personal. And what I mean by that, if you broke the test, if you break the test, you suffer. Okay? It's not if you break the test, your team suffers. It's not if you break the test, some other team suffers. You have to design it in a way that the person who broke the tests, who integrated a faulty code, is the person who has the most incentive to get it fixed immediately. Okay? This is a simple rule, but an example from my home yard. What is this? It's not Cyclone. Okay? This is the next, the new, advanced, modernized testing environment on a server level for a new product. It's called Typhoon, right? And it was supposed to be fast. With Typhoon, it's a server level test. We also failed in a way that we designed the system, but eventually the people who were writing the testing framework were the ones that they were most engaged in keeping it always green. So this was the team that was suffering if somebody else in some other team broke the code. So whenever they found that their tests are failing, they were just investigating, is it our framework or not? If it's not our framework, is it the test or not? It's not the test. You go to the team that actually introduced it in the product and ask them politely to get it fixed, right? You don't want that. You want to keep the feedback in a way that the person that broke it fixes it and knows about it as the first person. Okay. This is the last but not least rule that I have here. Keep it time constrained. set a limit from the very beginning how much or how long you can accept the test to take. Set it. If it's 10 minutes, set it 10 minutes. The extreme way of doing this, if it's more than 10 minutes, fail the tests. This is an extreme way. I've never tried it, but I encourage somebody, if you can, try it and let me know if it works. But at least if you don't do it an extreme way, measure it. Measure how much it takes for your continuous integration to get a feedback. A metric that we have actually, we are developing right now and will be automating it, is a measure how long it takes on average for one single commit on Git to get to a production system. It's a simple measure. You get commit and see when this code that was committed is actually in a production system, on average per commit. It's a good metric of your pipelines, delivery pipelines efficiency, also engineering processes efficiency, but that's a separate subject. So, recapturing, design it to be fast, make it personal, keep it time constrained, because, and out of all those three, this one is the most important. Design your continuous integration system, continuous delivery system to be fast, because if you do, then you don't have to deal with a lot of problems. Like, you don't have to deal with rollbacks. There's no concept of rollbacks if you have it fast. So if somebody integrates something, there's no regularly we deal with is how to roll back the changes to a previous state that is okay, that we have on production always working system. If you have it fast feedback, you don't have to do this. If you have fast feedback, you don't have to have this sophisticated promotion mechanism. If you have fast feedback, you don't have to have sheriffs or somebody guarding the people to do their work right. You don't need that lot of stuff, and you will not block anybody if you keep your continuous delivery system fast, because what you can do then is you can put all your eggs to one basket. I know they say don't put all your eggs to one basket, but I encourage you actually to do so. What I mean by that, if you have a fast delivery mechanism, you can get all the feedback on a pull request. So before you integrate the code, you commit your changes locally, then push it to a repository, and before it gets merged to your mainline or the official branch that your team is using, you give the entire feedback that you would have to the person that did it, and then if it passes, you allow the person to merge the code. With that approach, if it's fast, if it's below 10 minutes, you can do this. If it's 4 hours, you can't. So with 10 minutes feedback, you can move the entire feedback before the merge. And you don't need sheriffs, you don't need promotions, you don't need anything. And it's personal, and it's fast, and it's time constrained. Okay. Getting back to the very end of my presentation. You have this one? I'm not sure how many of you have this one, okay? So the things that I want you to do after this talk is whenever you brush your teeth, measure it, okay? Half a minute one side, half a minute other side, and then go to the bottom. While doing this, exercise your neck, legs muscles, so you improve your jogging, and reflect on your continuous integration. And you gain muscles, teeth, and mind. You meditate how long it takes for my team to get a feedback. How long it gets my team takes to get a feedback. How long it takes. 2 minutes, every brushing time, a couple of times a day, you will get your continuous integration better. Thank you. Any questions? Forgot about this.
Anybody want to ask a question?
Yeah, I'm open for questions. Not that I know anything, but...
Hi, Michał. Thanks for very good insights of what you have gone through just now. Just some questions on what are the specific things that you can, provide in terms of building the CI, design to be fast, make it personal and all that. Can you give some examples to those key points that you mentioned?
Yeah, I can give a couple of examples of the things that we did wrong. So, as I said, the cycle thing was the thing that we did wrong because we kept it long. We did run it in a specific order. It was a bad thing that we were suffering for years from that. The second thing that I think what we did very good is that when we created Typhoon, from the very beginning, we were eliminating instabilities. So knowing, and this is I kind of experience, like I wanted to ask everybody here, who have seen a large product, maybe not large, at least medium-sized product with a testing environment that has no instabilities? You're my God. So you probably have to ask that person. So all my experience with large products like we've been doing, at some point in time, you get to a point that there are instabilities in there. So the tests start to fail randomly for different reasons. Either it's simulators that you're using, either it's the test cases themselves that are written poorly, either it's the product. And we had cases, and not that few actually, that the product was behaving in an unstable way. So it was like doing something awkward every hour, for example, or every 100 attempts or something like that. So those kind of things you have to tackle. What we did is like we mark those tests that fail randomly unstable. We create in Jira bug reports for them, and they get to a team's backlog just like any other defect or story. So that thing I think we've done correctly. Now, there's a lot of things we've done wrong, so I'm not sure what exactly you're looking for. What we've discovered is also that the tools that you're using, they might be handy or not handy, that some of them are better, some of them are worse, but at the end of the day, the whole effort you put in them you have to put a lot of work regardless which tool you take, you have to put a lot of work to do the things that you want to do. Some tools get better integrated, some not, but that's not a problem. You can go with Jenkins, you can go with Concourse, with Bamboo, whatever. It doesn't really matter that much because eventually vast majority of the work is on your side. I'm not sure if I answered your question.
Yeah, you did. I think maybe there are part of things that are kind of similar because the reason I asked is because on the subscriber side, definitely we had instability problem with whether it's a radio firmware or whether it's a test system itself, right? So these are the common things that we see. We need to talk to Ahmed on how he has built a system that is like, running so well, no instability problem. But having said that, yeah, that's kind of things that we would like to hear. Right. But we can definitely talk more about some specifics down the road. Yeah, sure.
There's like the thing with audio verification, how you do it. It's like we also tried a couple of approaches, and right now I think we're in a better position. So yeah, we can have it offline. There's a question.
Michał, just a quick question about shifting the testing to the left, pretty much. Are you including your SIT, UAT-like testing, or is it purely unit testing?
So that actually varies right now in the product that I am on the component that it is. We have UI component that we call that we have this promotion mechanism, right, for different phases, but we've had so many failures in the late stages that we were pushing all the tests to previous phases, promotion phases. Now the UI component is the best example. It has all the tests in the pipeline, also in like pull request pipeline, but we've been exploring that options, and it's not that easy to do because we don't have that feedback short, and that is the main key reason. But yes, they do have a lot of feedback also from like static analysis tools. That you get that feedback. We're using a Fortify, for example, for security vulnerabilities checking. So that kind of feedback is also on the pull request, as far as I know. But yeah, we're definitely not there. So I'm preaching with things that I want my team to do, rather than things that I have entirely implemented.
Okay, so thank you very much.
Thank you.